Alright, so we have to simplify an expression. When we see a fraction made of two polynomials, that is called a rational expression. So we have this rational expression to simplify, and the most important thing is that we cannot subtract a number from upstairs and downstairs. It's only division and multiplication that we are allowed. So in this particular case, the only way we can cancel out terms if they are in a product. So the first and second problem is to factor the top and factor the bottom. So no one is telling you what kind of factoring techniques you should use. You can actually glance at things and see what the factors are, but because that's where we are with the material, I'm just going to use completing the square. It's kind of an overkill, but it's good practice. All right, so let's see the numerator. X squared plus 8x plus 7. Half of the linear coefficient is plus 4, so our complete square is x plus 4 squared. And when we expand it, we get x squared plus 4x gives us 8x plus 16. So we're going to smuggle in the 16 to have the complete square. So the first three terms gets absorbed, x plus 4 squared, and negative 16 and plus 7 combines into negative 9, which is good news, it's a square. So we have x plus 4 plus 3 times x plus 4 minus 3, which cleans up as x plus 7 times x plus 1. No one is really surprised. We sort of knew where this was going. Okay, so we can rewrite now the numerator as x plus 7 times x plus 1. The only way we can simplify this rational expression if first the denominator can be factored and one of the factors is one of these. Otherwise, we cannot simplify it. Let's see this one. So notice it's cubic, but it's not really because x can come out. So if we factor out the greatest common factor x, we get x times x squared plus 6x plus 5, which is also a fairly easy thing to factor. So half of the linear coefficient is plus 3. So we're going to expand x plus 3 squared, which is going to be x squared plus 6x plus 9. So we're going to smuggle in the plus 9. And so the first 3 gets absorbed into the complete square, x plus 3 squared. And then we combine negative 9 and plus 5, and that's negative 4, which is good news because it's a square. So we have x times x plus 3 plus 2. X plus 3 minus 2. Notice that we skipped a few steps, so we can speed up as we become experts in completing the square. So what we have is x times x plus 5 times x plus 1. So we go back to our fraction, rational expression, and the denominator is x times x plus 5 times x plus 1. And so the only thing that will cancel out is x plus 1. So the final answer has two forms, x plus 7 divided by x times x plus 5, or x plus 7 divided by x squared plus 5x. You see the difference. The polynomials are worked out. The polynomial in the denominator is worked out. So technically, this is more simplified, but to be honest with you, I don't like it. I don't like it because if we look at this rational expression and we ask ourselves, maybe this can be simplified, the first thing we would do is return here and see that there is nothing to simplify. So for me, this is sort of a more reasonable, smarter answer. But as I said, officially, this is the correct answer. I will accept both of them. Thank you for watching.